How do you use similarity in two-column geometric proofs? Imagine you're trying to prove two shapes are related in a special way, but you need a clear plan to show how. That's where similarity comes into play in two-column geometric proofs. When you use similarity, you're showing that two triangles or shapes have the same shape but not necessarily the same size. This is a powerful idea because it helps you connect angles and sides in a logical way. In these proofs, you start by looking at what you're given and what you need to prove. For example, you might be told that two angles are equal or that certain segments are proportional. Your goal could be to prove that two triangles are similar. To do this, you use the main similarity criteria, the angle-angle similarity postulate, the side-side-side similarity theorem, or the side-angle-side similarity theorem. The angle-angle postulate says that if two angles in one triangle are equal to two angles in another, the triangles are similar. The side-side-side theorem states that if all three pairs of sides are proportional, the triangles are similar. The side-angle-side theorem says that if two sides are proportional and the included angles are equal, then the triangles are similar. Once you decide which criterion to use, you write down your steps in the first column called the statements. For example, you might write, angle A is congruent to angle D, or side AB divided by side D equals side AC divided by side DF. In the second column, called the reasons, you cite the rules or theorems that justify each step, like given, definition of congruent angles, or proportional sides theorem. After establishing similarity, you can say that corresponding angles are equal and corresponding sides are proportional. This means that the shape is the same but scaled differently. You can then use these proportions to find unknown lengths or prove other properties. For example, if you know one side length, you can set up a proportion to find another. Using diagrams with markings for angles and sides helps you visualize which parts match up. It makes your proof clearer and easier to follow. When you write your proof, each step should logically lead to the next, showing how the similarity was established. This way, you can confidently use the fact that the triangles are similar to prove further relationships or solve problems involving lengths and angles. In essence, applying similarity in two-column proofs involves carefully showing that angles are equal or sides are proportional, justifying each step with geometric rules, and organizing your reasoning so that the conclusion about shape similarity is clear. It turns complex shape relationships into simple, understandable steps that help you solve many geometric problems efficiently.